AP Statistics, hello. Okay, so in this video, we are going to compare proportions with means, or if you want to think of it as categorical compared to quantitative. So I thought this comparison, this side by side, might help you prepare for your test a little bit. So here we go. So over here on the left, we are given information on a packet of seeds, claims that germination rate is 92%. The packets usually contain about 2,000 seeds. What is the probability that more than 95% of 160 randomly selected seeds in the packet will germinate? Be sure to check the conditions. Okay, so I've given you this problem in a homework, but I just wanted to go through it and look at the fact that, okay, ask yourself this question. Am I dealing with categorical or quantitative data? Well, if you'll notice, it says information on packets of seeds claims that germination rate is 92%. So if you'll think about it, the seeds are either going to germinate or not. So in other words, you've got 92% germinating, and that would be about 8% not germinating. So this should be a dead giveaway that we are dealing with categorical data. Okay, so this is definitely categorical. So notice that we have a sample size of 160, and we want a probability that more than 95% of them germinate. So anytime I've got a sample, that means that I'm going to, of course, have to check my conditions. So what would this look like? Well, the first thing I'm going to do, all right, was I told they're randomly selected? Yes. So 160 seeds were randomly selected. Neato. All right, so if I've got 2,000 seeds, let's check our 10% condition here. Let's see, 10% obviously of 2,000 is going to be 200, so 160 is definitely less than that. So 160 seeds is less than 10% of all these seeds. And then the seeds are independent. There's no reason to believe they're not. Okay, and then since we're dealing with categorical, we have a P here. It is 0.92, the percentage that will germinate. So I've got to have my NP rules here. So I take 160, I multiply by 92. I get 147.2. And then 160 times 0.08 gives me 12.8. Do I need to make a statement here? Absolutely. The sample is large enough to approximate normal, and my handwriting is horrible. Okay, and then of course what we need to do once we've got our conditions, we need to calculate, I shouldn't have written an X there. We need to calculate the standard deviation for all seed, what's the word I'm looking for? Sample sizes of 160. So I'm going to take the square root of 0.92 times 1 minus 0.92, which is 0.08, and divide that by 160. Be careful here. Notice that that 160 is inside the radical. So please, please be careful with that and make sure that you're doing that correctly mathematically. So I get 0.0214. So I have this normal distribution here with a P of 0.92, because remember the mean of this, of P hat, is equal to P. So I was given the P as 0.92, so I now have this distribution right here. That's called your sampling distribution. When you're asked to describe the sampling distribution, that's what you're doing. And then of course we are going to use that information to find the probability that more than 95% are going to germinate. So the probability that P hat is greater than 0.95. And of course, at this point, we'll use Staplet, or we can use our calculator or whatever to figure that out. Okay, so that's how you go through a categorical distribution. So let me switch colors here and look over here on the right. I have assessment records indicating the value of homes skewed to the right with a mean of 140,000 and a standard deviation of 60. To check the accuracy of the assessment data, officials plan to conduct a detailed appraisal of 100 homes selected at random. What is the probability the mean value of these homes is above 180,000? Okay, so if you'll notice, there should be a dead giveaway here. There's not a price that the house fits into, like a category. Every house is going to have its own value, its own separate value, and those get averaged together to give me this mean. And notice you are given a standard deviation. In this problem over here, you are not given a standard deviation because the formula for mean to find standard deviation requires that you have one. All right, so I'm running out of time. I'm making this video too long. So of course, conditions. The conditions that are going to be the same, randomly selected, 100 homes. And I'm sorry, my handwriting is bad. We're randomly selected. I'm trying to hurry. 10%. It's safe to assume that 100 homes is less than 10% of all homes. Are the homes independent? Probably. And that's where things cease to be the same. Okay, we cannot use the MP rules for quantitative data. Look at what's happening here. We are told that the initial distribution is skewed to the right. So we have to look at this 100 here. It is not normally distributed, it's skewed right. So 100, since it's bigger than 30, the CLT tells me that the sample is large enough. So sample is large enough by the CLT to, can I spell? Approximate normal. Okay, so that condition is different. Okay, so let's do a little highlighting here. It'll be neat. Let's pick a pretty color. Okay, see, this condition is different for these. Okay, that's where we have a difference right there. Okay, now I've got to get a standard deviation for X bar. It requires the use of an already existing standard deviation. And then I have to divide that by the square root of 100. Oh, that's just by 10, and here I am putting in the calculator. Okay. So that's 6,000. The mean of X bar is equal to the mean you were given. Just like this is equal to P over here, this is equal to the mu that you're given already. So my distribution is 140,000 and 6,000. You know what? Let me erase that decimal, or that comma. That's not good. Okay, so now I can use that to answer a question. And this is going to be the probability is above that. So the probability that X bar is greater than 180. So I want you to notice that this is also different, okay? Right here, that's different, and our formula is different for standard deviation. Okay, so those are the things that you need to recognize as you're going through this that are going to be alike. Some things are alike, some things are different. So you've got to be able to determine that difference in your head. Hopefully this has been helpful.